In this lesson today, we're going to talk about the concept of theoretical probability. What theoretical probability is in theory, this should happen. We like to look at it as this little ratio up here above, that theoretical probability is the number of possible or favorable outcomes over the total number of possible outcomes. Now, before we start looking at calculating theoretical probability, we need to understand this notation here that you see. When you have a P in parentheses, that just means the probability of an event occurring. And then you're going to have the event listed in the parentheses. So let's go ahead and determine the probability of each of these events occurring below. Let's go ahead and look at the first spinner. We have a spinner with 3 equal sections. Each of them are a different color. They're also labeled 1, 2, and 3. We want to know the theoretical probability of spinning a 2. That's what that means with the P and 2. The event that we would roll a 2, what is our theoretical probability? So in theory, we can see that there is one space that has a 2, with 2 others that do not. So we can say that the probability of spinning a 2 would be 1/3. And that's it. In theory, we should roll a 2 1 out of 3 times. Now let's look at odd, the probability of spinning an odd number. You can see that we have 2 odd numbers on our spinner. We have a 1 and we have a 3. So the probability of spinning an odd number is going to be 2 out of 3 times. And we're done. Okay, let's look at the next spinner. We want to know the probability of spinning a blue. So the first thing we need to really recognize here is, well, how many spaces are there to choose from? And it looks like there are 8 equal sections on this spinner. So if we want to figure out how many blue, there are 3 of them. So we have 3 out of 8 different spaces. So our chances of spinning the spinner and landing on a blue are 3 out of 8 chances. And then the last one is the probability of spinning an even number. So I'm going to go ahead and circle all of my even numbers. So I have 1, I have 2, I have 3, and I have 4. So I have 4 equal spaces that I could potentially spin an even number. So I have 4 out of 8. Now, notice something about this fraction here, 4 out of 8. You're probably thinking, well, 4/8, doesn't that simplify? Isn't 4 half of 8? And you're exactly right. We always want to simplify all of our fractions when we're working with probability. So I can simplify 4/8 by dividing both of them by 2. So that's going to give me dividing both by 4. That's going to give me 1/2. And that is going to be my final probability. I usually like to put a box around my final probabilities just so that I know what my final answer is when I'm simplifying. Okay, let's go ahead and look at some more theoretical probability. It says here, determine the probability of each event occurring with a fair number cube. A fair number cube is just a dice or a die. It has 6 sides and it's labeled with dots from 1 to 6. So anytime you see those words fair number cube, that just means a dice. So what's the probability of rolling a 4? Well, the chances of us in theory that we would roll this dice and we would roll a 4, well, there's only one side that has a 4 on it. So that would give us 1 out of 6 different sides of the die. 1/6 is fully simplified, so I am finished determining my theoretical probability. All right, the probability of rolling that dice and landing on an odd number. Well, if you think about the numbers on a die, I'm going to write them right here. We have 1 all the way to 6. So if we're trying to figure out how many odd numbers there are, well, we have a 1, we have a 3, and we have a 5. So we have 3 out of 6 different options or different sides that we could land on for it to be odd. But 3/6 is not simplified because we can simplify that down to 1/2. So my theoretical probability of landing on an odd number is going to be half, which means half the time that I roll a die, I should land on an odd number, in theory. Okay, how about 3 or higher? I'm going to go ahead and list out those numbers one more time. let's see if we can figure out the probability of rolling a 3 or higher. So the probability of rolling a 3, I'm going to circle that 3, and then every single number that's higher than it. So it looks like I have 4 out of 6 different times I could actually make that happen. 4 6 is not simplified. We have to simplify that down. And if you think about it, we're going to divide both the top by 2 and we're going to divide the bottom by 2. So when we do that, 4 divided by 2 is 2 and 6 divided by 2 is 3. So the chances of that happening in theory would be 2/3 likely. How about a 1 or a 6? Well, if I write it out again, 1, 2, 3, 4, 5, and 6, I have a 1 and I have a 6. So it looks like that's going to be 2 out of 6 times, which again, we can simplify that by dividing it by 2. So I can simplify that down by 1/3. So the chances of us doing that is about a 1 1/3 chance or 1 in 3 chance. Okay, now let's look at a different type of problem with theoretical probability. So we have a tiny jar of jelly beans, and the jar has 15 green, 10 red, 5 yellow, and 20 purple. Oh, and 10 black jelly beans as well. Determine the following. We want to figure out the probability of reaching into that jar and pulling out a green jelly bean. What are the chances of that actually happening? Well, in theory is what we want to do. So before I even begin this problem, I need to know how many jelly beans are actually in the jar. So I'm going to begin by grabbing all of those numbers. I'm going to grab my 15 green, 10 red, 5 yellow, 20 purple, and 10 black jelly beans. And what I'm going to do is I'm going to find the total number that I have. So I'm going to add 15 plus 10 plus 5 plus 20 plus 10. And you can absolutely use a calculator for this. They're pretty simple numbers, but feel free just to double check yourself. And it looks like I have a total of 60 jelly beans. Okay, so that is going to be the total number that I have to choose from. Now, let's go back to the question, the probability of selecting a green one. Well, how many green are even in the jar? Well, 15 are in the jar, so I'm going to write 15 out of the total number of jelly beans, which is 60. Now, you may be thinking, well, can't I simplify that? And you're exactly right. We can. So we can actually put 15. We can divide 15 by 15, right? And we can divide 60 by 15 as well. That's going to give us 15 divided by 15 is 1. And then 60 divided by 15 will give us 4. So we have about a 1 in 4th chance of actually that happening. So, and if you remember back in Unit 3, we talked about fractions, decimals, and percents. So that fraction actually equates to 25%. So we have about a 25% chance of that actually happening, which isn't a very high chance, but it could happen in theory. Okay, now let's go ahead and look at the next one. The probability of it not being red. Okay, so let's first figure out how many red we have. We have 10 red. So we want to figure out the probability of the other ones because we're not going to focus on that red. So if I take 60 and subtract the red ones out of it, that's going to leave me with 50. So my probability is going to be 50 out of the total of 60. Now, that is definitely not simplified at all because I can simplify both of these by 10. So I can divide both sides of these by 10, which would leave me with 5 out of 6. And so my chances are 5 out of 6 times that would actually happen. I would choose a color that's not red. Now, you might be thinking, well, you know, what is this, the decimal of 5 6? Well, that is equivalent, just out of your curiosity here, it's about 83%. So that is pretty likely that might happen. At least it's a high probable event that could occur. Is it always going to happen? No, but it's pretty likely that it will. All right, let's focus on the next one. Probability, find the probability of selecting a yellow or a purple. So now we want to focus our attention on the yellow and the purple. So we have 5 yellow, and there are 20 purple in the jar. That gives us a total of 25. So if we were to reach into the jar, there are 25 jelly beans that we could possibly choose that would satisfy this probability. So I'm going to write 25, And the total number of jelly beans that I have in my jar is 60. So I have 25 divided by 60, which is going to simplify down to 5/12. And all I did there was divide it by 5. So you can divide the top by 5 and the bottom by 5 because both numbers are divisible by that number. That gives me a probability of 5/12. Now, 5/12. If I just kind of think about what the percentage would be, in my calculator, I determined that this was approximately 41%. So not quite 50%, but almost there. Okay, let's go ahead and try this last one. The probability of a blue. So we have, if we look up at the top, you can see that we don't have any blue in the jar. If there aren't any in the jar, you can't possibly choose one. So the probability of us choosing a blue is going to be 0 out of 60. Now, 0 out of 60 does simplify. Anytime you take the number 0 and divide it by any number, your answer is always going to be 0, which means that there is a 0% chance of it actually happening, pulling out a blue out of a jar that does not have any blue. Okay, that is all we have for theoretical probability. We're going to move into experimental probability next.